looking at polynomials, and within the polynomial functions unit, we're going to be looking at how to find zeros through synthetic division, through long division. We're going to look at how the polynomial function operates, so what transformations we can put on a polynomial function, and the characteristics of it. But in order to understand what a polynomial function is, we have to look at its form. Okay, so this right here is the polynomial function. I can't say that for some reason today. Saying it too many times, I think. And I'm going to start here with A0. Okay, all of the letter A, so A0, 1, 2, going, those represent your coefficients. And if there's no variable, what do we call it? Say, for example, I had 3x squared plus 2x plus 8. What do we call our 8? It's a constant. Okay, so the a's, they're just numbers. And if it has no variable, we call it a constant. Okay, when we have x, that's our variable. And we say the term with the highest power on the x, or on the variable, that tells us our degree. And it's also our leading term. So if we kept going, so we have a constant, it actually does have a variable, but it's x to the power of 0. And then next we have x to the power of 1, x to the power of 2. And the power on x is just increasing by 1 each time. We're going to start from the left-hand side, the term with the highest degree, that would be n, and it would go down by 1 each time. Okay, see how it's decreasing by 1? Now, how can I say that the constant is x to the power of 0? Good, because x to the power of 0 is just 1. And it's going to be 1 no matter what value of x we put in there. Okay, so if we just have a constant, the degree is 0. But we're going to get to some more examples of that later. So a polynomial, although this looks complicated, is just simply writing in order the terms from highest power to lowest. And you're typically going to end with a constant. Okay, and just to summarize, the values a1, 2, all the way up to an, those are your coefficients. The term in front of the variable with the highest degree, or the highest power, is always called your leading coefficient. Okay, and then the last term where there's no variable, that's independent of x, we call our constant. And the term with the highest power, in this case n, that would give us or reveal the degree. You guys remember the degree from grade 10? It's basically the highest power. So we have a few examples we're going to talk about, but the first one is x to the power of 4 plus 7x cubed minus 8x squared plus 5. And we have to determine the degree, the leading coefficient, and the constant. So what is the highest exponent on the variable? 4. Okay, so that's going to tell us our degree. What is the coefficient on that term? Okay, because our leading coefficient always comes from the term with the highest power. So it's 1, and the constant is the term without a variable. That's 5. So it's also important to know what characteristics reveal that you do not have a polynomial. Okay, and there's 4 important characteristics that would reveal that. So expressions containing roots of variables, negative or fractional power, or coefficients that are non-real tell you that you do not have a polynomial. We have a bunch of examples here we're going to go through and see if any of these non-examples exist. Okay, so our first example, negative 5x cubed plus x to the power of 1/2 minus 4. Is it a polynomial, yes or no? You think yes? Go through the list, which tells us it's not a polynomial. Okay, good. We have a fractional power, therefore it's not a polynomial. So because we have an exponent that's a fraction, it's not a polynomial. Let's look at B. Is there anything that's telling us we do not have a polynomial? Are there roots of variables? Are there negative or fractional powers? Or are there non-real coefficients? We have a negative power. And because of that, no, this is not a polynomial. Looking at example C. Do we have any negative exponents, fractional exponents, roots of variables, or non-real coefficients? None of those, so yes, this is a polynomial. D, yes or no?
No.
Why not? Good. We have a root of a variable. And let's just talk about this for a second. Let's just pretend we had the square root of x cubed. How could I write that in exponential form? X to the power of 3 over 2. Do we have a fractional exponent?
No.
Yes. So this is not a polynomial. Next one.
No.
Yes or no?
No.
This is a tricky one. Okay, if we look here and we were to simplify the square root of x squared, does that not equal x? So if you can simplify it, then do so. And in that case, we no longer have a root of a variable. So this one actually is a polynomial. And that's because a square root of a square, they eliminate each other, and we're just left with the variable x. Right, next one? Why not? Good, you're not allowed non-real coefficients. They can't take negative square roots, it's non-real. And because of that, this is not a polynomial. No. So I said there'd be a few more examples. Sometimes they are disguised as to which is the leading coefficient or the leading term, I should say. So taking a look at example A, 34x squared minus 25x cubed plus 2x minus 39. What's the highest power? 3. So if I were to rewrite this, typically you go in decreasing or descending order. You have negative 25x cubed plus 34x squared plus 2x minus 39. 3 is your highest power. So your degree is 3, and the leading coefficient on that term is negative 25. The constant is the term without a variable, negative 39. Okay, the next one, we have a binomial times a binomial. Do you think I can tell the degree just right now? It's kind of disguised, but Bernie's shaking his head yeah, because when you multiply the variable times the variable, what do you get? Okay, you get 10x squared. And so we have degree 2. So there's no other terms that have variables, so if you multiply the highest power variable times the highest power variable, then you get the degree. And at the same time we multiply the coefficients, so the leading coefficient would be 10. What two numbers would I multiply to find the constant? Yeah, the two constants, right? So negative 1 times 7, negative 7. And if you're unsure, you would just fully FOIL. Okay, do I care about these two middle terms? Alright, now there's going to be some times where you're going to need to work a little bit quicker. So rather than fully foiling or expanding every time, you should be able to look at a list of factors in a polynomial and decide what's the leading coefficient, what's the degree, what's your constant. And I'm going to show you a shortcut to doing that. So let's just start, I'll start easy. Let's work with the constant. Constant will have no variables. So I've got to multiply the numbers that have no variables. So that's a 1, the negative 1, don't forget that it's squared, and then the 2. So if I multiply 2 times negative 1 squared times 1, I get 2, and that's my constant. And that's something you can do in your head as well. 2 times negative 1 squared, that's 2. 2 times 1 is 2. So you're just looking at the numbers without variables and multiplying them through. Now, you just have to be really careful because in this binomial here, it's squared. So say I had like a 4, if you didn't square that, that'd really mess up. Okay? And similar here, if I didn't square it, I would end up with a negative and that would be wrong. So you have to make sure you square. Alright, now we need the first term in this polynomial. So we've got to pick the term in each polynomial or factor that has the greatest power. So 3x does and 5x squared does. So in order to figure out the front term, the first term, we would go 2 times 3x squared, don't forget about the squared, times 5x squared. So we're taking the factor out front, 2, or the coefficient out front, 2. 3x, it has the highest power in this binomial, don't forget it's squared, multiplied by the highest power in this trinomial, 5x squared. So we're multiplying that out, and we get 2 times 9x squared times 5x squared. So that leads us to get, we have 45, that's 90, x to the power of 4. So the degree is 4, and the leading coefficient is 90. Now I did that all together. Do you think there's an easier way to think about it, maybe separately? I'll just run through it one more time. Without all that work. Okay, let's start inside this binomial because I got to remember to square it. 3 squared is what? 9 times 2 is what? 18. Times 5? 90. Okay, that's my leading coefficient. Okay, now let's just look at the variables to figure out the degree. X squared times x squared. X to the power of 4. So you have degree 4. So you can do it together or separately. Jackson, how are you doing? Pondering?
Pretty good, yeah.
Do you want me to go through it again?
No, I think I'm okay.
We're going to do one more example, so if you have questions, let me know. The difference between this example and this example is now instead of multiplying all the factors, we actually are adding this last trinomial here. So if we need to figure out the constant, we're just going to look at the terms that don't have variables. So we have 2 times negative 1 squared, which is 2. 2 plus 1 is 3. Okay, so I'm just looking at the terms that don't have variables. You're multiplying 2 times negative 1 squared. That gives you 2. 2 plus 1 is 3. Now do you want me to go slower?
Oh, no, sorry, I didn't mean it like that.
No, just making sure. Do you want me to write it out?
No, I got it.
Okay.
Yeah.
I'm just making sure. Okay, now let's look at the degree. In this binomial, what's the highest power? The 3x, right? Okay, x squared is x squared. If I'm adding a term that also has x squared, has the degree changed? So if I had 9x squared plus 5x squared, I guess 18x squared plus 5x squared, do I still have x squares?
Yeah.
So degree is 2. Now let's look at the coefficients. Okay, this term's the highest power and it's squared, and this term's the highest power, and I have to multiply by 2. So we have 2 times 3 squared, so 2 times 9 is 18,
Bless you.
plus 5, 23. So part 2 and simplifying or whatever, it's just verifying, so we would actually expand this out to make sure that we did get the correct answer. To save ourselves a little bit of time, I'm just going to verify that it did work out. And it's going to save you a lot of time too, right? Like think about this alone. You'd have to FOIL it. Then you'd end up with a trinomial. And from that trinomial, you would distribute the 2 into that. And then you would have to distribute the 3 terms from the trinomial into the 3 terms of that trinomial. So you'd have a lot of terms that you're distributing. So I'm just going to save us a little bit of time. Do you like our shortcut now? Yeah? Alright, so we have a polynomial, it's just equal to 7, a constant. Explain why the polynomial p of x equals 7 has a degree of 0. So for example, if I had 3x squared plus 7, why does this term have its exponent giving the answer away? Hey, you just have a polynomial, 7. Okay, what's the degree? Is there a variable? There's no variable. So if there's no variable, it's degree 0, and the reason why is because 7 times x to the power 0 is like 7 times 1. The degree is 0. Does it matter what we put in for x?
No.
If we have anything to the power of 0, will it always equal 1?
Yep.
Therefore, for part B, they're asking why we call it a constant. And it's because no matter what we put into the x term, it will always equal 1, because anything to the power of 0 is 1. And if anything to the power of 0 is 1, 1 times 7, the 7 remains constant. No matter what you put in for x, 7 will always be 7. No matter what we put in for x, x to the power of 0 will always be 1. 1 times 7 is 7. So there's 3 different ways that we can classify a polynomial. Number of terms, by degree, and also by the coefficients. So classifying by the number of terms, I'm sure you guys have heard of a monomial, a binomial, a polynomial, a trinomial. Yeah?
Yep.
So number of terms classifies polynomials in some way. So a monomial, how many terms?
1,
1. Binomial,
2,
trinomial.
3.
Anything more than 3? Poly, good. Okay, then also we just talked about it. We have a degree, and the degree tells us also what kind of function we're going to have. So for example, if we have a constant, we just talked about it, it's degree 0. If it's degree 1, okay, we have a linear equation. If it's degree 2, quadratic, degree 3, cubic, and degree 4 is quartic. Now I'm just going to help us on part B. You can research on your phone right now if you want. But if we had degree 5, we call that a quintic. Maybe I'll write them out. Quintic. Degree 6 is a hexic. Degree 7, heptic. 8, octic. 9, nonic. and 10 dekic.
Something happened?
So if you ever see an example that says a hexic polynomial, you should know it's degree 6.
You say seven. Practice in French.
Am I writing kind of messy? Hexic.
You gotta know that one.
Is that better? Sorry.
What's awesome?
The first one's quintic for 5.
The old octave. That sounds like try. Is it quintic?
Quintic, yeah.
Lindsay, let's straight to quintic.
So let's go through a few polynomial functions and we'll summarize the degree and the type.
Quintic, you heard someone read
P of x equals c.
quintic's
What degree? 0. What type? Constant. Good. What kind of polynomial do we have here? Degree 1. Linear. Okay, what's the degree on this trinomial? 2. And so if we have degree 2, what is it? Quadratic, good job. And degree 3? Cubic. And degree 4? Quartic. The last type of classification is by the coefficients. So we can have integral, we can have rational, or we can have real. And it's all based on what the coefficients look like. So in the first example, we have 3x to the power of 4 minus 5x squared plus x plus 7. All of the coefficients are integers. So in this first example, they're integers. In the second example, if you take a look at the coefficients, we have 3, -2 over 5, 1, 7. Okay, the 3, the 1, and the 7, yeah, they're integers. But the -2 over 5, that's considered a rational number. So as soon as you have one rational number, it's classified as a rational polynomial. Okay, rational is also described as a fraction. And if you were to divide those numbers, so say 2 over 5, you would get either a decimal that terminates or a decimal that repeats. This is going back to grade 10 stuff. So if you get a non-repeating decimal, so it doesn't repeat, but it just keeps going. So a non-repeating and a non-terminating decimal, what kind of number do we call that? Not a rational, but a irrational number. Good. Okay, and in that case, so for example, like if we took the square root of 3, you would get a decimal that doesn't end and it doesn't repeat. That's considered irrational. Okay, and then here we have a rational, a real, or an integer, and an integer. Okay, so we have integers, rational numbers, and irrational numbers. So pretty much everything. In that case, we say that we have all real numbers. Okay, they're just a mix of numbers that are real. So as soon as you have a coefficient that is not all integers or not one rational, then you just say real. So if it's a mix of numbers that go beyond integers or rational numbers, you just say it's real. On the next page, we have a few examples that you get to come up with. We have to write a polynomial that satisfies the conditions given. So we need to create a trinomial that's quartic and integral. So trinomial, how many terms?
3.
3 terms. Okay, if it's quartic, what's your degree? 4. And if it's integral, what does that mean?
Integer.
The coefficients are integers. Awesome. Okay, I need an example. Who can hook me up? Okay, 4x power 4
Plus 3x squared.
plus 3x squared.
Minus
1 million? Okay. Awesome. Trinomial, we have 3 terms. Highest power is 4, so it's degree 4. And every coefficient is an integer. Brilliant.
Linear. Real.
Binomial, how many terms?
Yes.
Linear, what's your degree?
3.
And real? To have anything as your coefficients.
Wait, so does that mean that integral and rationals are also real?
Yes. Yeah. Your real numbers are made up of integers, whole numbers, natural numbers, rational and irrational numbers.
Okay. But but do you only classify it when you have a mixture?
Yes, so if it was a integers and a rational number, I'll just go back to that example. So see here how we had integers and a rational number?
Yeah.
We call it, even if there's one rational, we call it a rational one.
Yeah.
If they're all integers, we call it integers, or integral. Okay? So even if there's one example that's rational, it's a rational polynomial. Okay, in this case we have integers, we have rational, and there's one example of an irrational.
Yeah.
So in that case it'd be a real polynomial.
But like, technically, integral polynomial is a real polynomial.
Yeah, and a rational polynomial is also a real.
Yeah.
Yeah, they're all real numbers. Okay, let's just go back here. We had the second example needs 2 terms, degree 1, and real numbers.
3x plus 2.
Brett, you got an example for us?
For the C,
For B,
yeah, 2x plus
3x plus
7.
7, okay. Now it's real. Should we put maybe a number that would be not an integer or not a rational number? Maybe like square root of 7? Okay, so we need something other than an integer and a rational number. And the last one, monomial, how many terms?
Quadratic.
1 term. It's quadratic. Degree what? 2. I know it's tricky because we always talk about quads as like 4 wheels or something like that. But we've been also talking about quadratic functions and parabolas for a few years now. So hopefully we know quadratic means degree 2 plus x squared, and it's rational. So we need 1 term that has degree 2 with a rational number as its coefficient. Maybe 1 over 3, yeah, x squared, perfect. Got it? Very good.
Isn't that irrational? And what's the difference between rational and irrational?
So, irrational numbers do not terminate and they do not repeat. Whereas rational numbers, they can repeat and not terminate. So irrational don't repeat. This decimal is 0.3 repeated.
Oh, but if it's just a bunch of random numbers?
Yeah, if it's just a bunch of random decimals, irrational. So if the decimal terminates or repeats, it's a rational.
Yeah, okay, now I
I
get
said
it.
a, but I didn't want it to sound like irrational. So it's rational.
Thank you.
Alright, now we're gonna start getting into the good stuff. We're gonna be solving for unknowns. Now that we know the definition of a polynomial and how to classify it, we can start solving and evaluating. So hopefully we did well on the functions part of our midterm, because guess what? Function notation comes up again and again. We have a function that's a polynomial. The polynomial is negative 3x squared plus ax plus 8. They're telling us in function notation that our polynomial when x equals 1 is equal to negative 9. So the polynomial replaced with 1 equals negative 9. So why don't we just start by figuring out what p of 1 is on the right hand side. What does p of 1 mean again? Said it twice. Say that a little louder.
Sub x for 1.
Good, we're going to put a 1 in for every x that we see. So we have negative 3 times 1 squared plus a times 1 plus 8. If I clean up the right hand side, negative 3 times 1 squared is negative 3. A times 1 is a plus 8. Going a step further, negative 3 plus 8 is 5 plus a. So p of 1 equaled that. But instead of writing p of 1, what could I actually say p of 1 is? Where'd you get that? Good. Okay, we got to use the hints that are given. Okay, p of 1 actually equals negative 9. So instead of writing p of 1, okay if I put negative 9 now? Thank you. Now we just solve for a. So subtract 5 over, and we get negative 14. Next question, do you guys remember solving systems of equations from grade 10? 2 unknown variables, solving systems? We're going to do a little bit of that. It's just a nice review today. So similar to what the skills we just used in that example number 8, we're going to do that, but there's 2 clues this time. So the goal is we have to determine the values of a and b given this polynomial. P of x equals negative 2x squared plus ax plus b. They're telling us that p of 2 equals negative 18 and p of negative 3 equals negative 13. So we're going to use both clues to create a system of equations that will then solve for a and b. So let's start with clue number 1. P of 2 equals negative 18. Let's start with p of 2. If I'm replacing x with 2, that means all the x's are replaced with the 2 in the polynomial. So I have negative 2 times 2 squared plus a times 2 plus b. Before I go to the next step, instead of writing p of 2, what can I write instead? Negative 18. So negative 18 equals negative 2 times 4, negative 8, plus 2a plus b.
It's close.
I know what you meant. You love it. Now we're going to add the 8 over, and we get negative 10 equals 2a plus b. That was pretty cute. So we're going to save this equation for a little bit later. Now we have to apply clue number 2. So p of negative 3 equals negative 13. Using the same strategy that we just did above, we're going to solve for our second equation. Okay, so p of negative 3 equals negative 2 times negative 3 squared plus a times negative 3 plus b. The clue told us that p of negative 3 equals negative 13, so I'm going to replace p of negative 3 with negative 13 and just evaluate the right hand side. What's negative 2 times negative 3 squared?
Negative 18.
Good job. A little more confidence this time though, right? Okay, so it's basically like 9 times negative 2, we get negative 18 minus 3a plus b. So if I add 18 to the other side, I get positive 5 equals negative 3a plus b. Moving arrow. And we're going to save this equation for our next step as well. So notice that from each clue we have created a simplified equation where we still have unknowns a and b. So whenever you have two equations with two unknowns, you have to solve the system. And that's going to help us solve for a and b. So the first way we're going to solve this is by elimination. And then I'll review how to solve the system by substitution. So with elimination, you need to stack the two equations on top of each other. And you always want to have it as the constant is equal to the variable. And it's important when you stack them that the same variables are over top each other. So we have negative 10 equals 2a plus b. And underneath we'll put 5 equals negative 3a plus b. Now in order to eliminate a variable, we want to pick the variable that has the same number of each. In this case we have 1b and 1b. So to eliminate a positive and a positive, we would subtract. Let's start with the b's. B minus b. Did they cancel out? And that was the goal. Okay, 2a minus a negative 3a. It's like 2a plus 3a. So we have 5a. And we have negative 10 minus 5. Don't forget to subtract. We have negative 15. Divide by 5. And a is equal to negative 3. So we've solved for our first variable. How do I solve for b? Plug it in where? Easiest place to sub it into is either this equation or that equation. So the simplified equations that we found before. So let's sub into 5 equals negative 3 times negative 3 plus b. Move the 9 over, and we get b equals negative 4.
Does it matter which one you put in?
No, if you put negative 3 into here, you get negative 6. Add the 6 over, negative 10 plus 6, negative 4. So it's up to you which one you want to plug it in, doesn't matter. Now typically when you solve a system, you have to make sure that your a equals negative 3 and your b equals negative 4 in both equations. So you'd want to just sub it into both to verify. Should we review substitution? Some people like that a little bit better. Actually wait, before we do that, say for example I had 4 equals 2a plus 3b and 2 equals 4a plus 5b. How would I eliminate in this case? Do you guys remember the rule? Yeah. So say for example I wanted to eliminate the a's. I would only need to multiply the top equation by 2. Because 2 times 2 gives me 4a. So you just multiply that through each, and from there you have 8 equals 4a plus 6b. Now you can subtract the a's to eliminate them. Okay, so just a little reminder from grade 10. I think that took a whole unit and it's just like 5 minutes in grade 12. Okay, substitution. Now this is just to remind you guys in case you prefer this method. Okay, so again we had negative 10 equals 2a plus b. First thing you want to do is pick one of the equations and isolate a variable. So let's isolate b. If I rearrange, I get b equals negative 10 minus 2a. Then I'm going to take the b, and I'm going to sub that into the other equation, which is 5 equals negative 3a plus b. So if I do that, 5 equals negative 3a plus, what was b? Negative 10 minus 2a. Then you rearrange, solve for a. So we get negative 3a minus 2a gives us negative 5a. And if I move that negative 10 to the other side, I add it. So 5 plus 10 is 15. Divide by negative 5 and we get a is negative 3. Then, what do I do with that a? Well, let's plug it back into the b that we just isolated. So b is equal to negative 10 minus 2 times negative 3, that equals b. So negative 10 plus 6, negative 4. Do we have the same thing?
Yes.
Yes. Yeah, let's polynomials. You guys must be tired all these midterms and